Hey, g'day, it's your old mate Prezzo here. Starting a new project today, and here are all the meaty bits that are going to become part of this project. If you are watching this, you probably have an interest in machining and engineering and power tools, that sort of thing. And I'm pretty sure you've probably come across Mr. Pete, or Tubal Cain as he calls himself. And he's done literally zillions of videos on model engineering and engineering processes. And one that caught my attention just recently was a device that is known as a pull gear. These are apparently available back in the 50s and 60s, and they were an accessory for a drilling machine which allowed you to get an extra low range of speeds from the drill press. And my drill press, which we'll have a look at in a minute, I have the same problem. I cannot get enough torque at low speeds to use large drill bits and large hole saws. So the pull gear is a patented product, but evidently they're not available anymore. And in Mr. Pete's video, he showed some patent drawings which demonstrated the internal workings of this thing. And I took one look at it and I figured that I can make that. So what I have done is I've purchased some gears. I don't have facilities for making a ring gear like this one. And what I have is enough gears to be able to make or replicate the mechanism that I saw in Mr. Pete's video. So what we have now is a epicyclic gear mechanism. And the notion is that if you were to rotate this central pinion, it would in turn rotate the other set, which are all the same number of teeth, and they in turn would drive this ring gear around the outside. Or if you were to lock the ring gear and rotate the central pinion, then the epicyclic, or these extra 4 gears here, are going to rotate around that central pinion. And that is the mechanism that I want to replicate for this drill press. So let's take a look at the drilling machine and the problem I have with that, and then let's have a look at the drawings of this device that we need to make. This is my drill press. This is a Toolex brand. It was Taiwanese, and I think it was manufactured sometime in the late 70s. This one I purchased second hand. When I bought it, the pulley system on top was partially incomplete. It originally had a 2-belt system driving intermediate set of pulleys, but because that was missing, I decided to upgrade it to a Poly V drive. I had read in a magazine years ago that Poly V drives are generally quieter, they run cooler, they can transmit more torque around smaller diameter pulley sheaves. The only problem with this configuration is that I have a Hyungyang VFD driving a 3-phase motor. I think it's a 0.75 kilowatt 3-phase motor. On 50 Hertz I can get a lowest speed of 480 RPM. Even at 480 RPM, if you're using a large diameter drill bit, say a 16mm or 20mm drill bit, that's really too fast. And if I lower the speed of the motor by adjusting the hertz, or the frequency of the drive, then the power drops off as well. I've got the frequency set on the drive at the moment at about 18 Hertz, maybe 19 Hertz, and if I switch the machine on, you can see that on my lowest pulley configuration, or my lowest ratio drive, that's about the RPM that I'd want to run a large diameter drill bit at. And the only problem is that you lower the speed or the frequency, and you also lower the torque. So I can just grab hold of that chuck and I can effectively stop it. So that's really not sufficient torque to drive a large diameter drill bit, and that's what I'm hoping this pull gear is going to address. Okay, so in order to get this project underway, what I need to do is to make 2 castings for this pull gear. This is the pattern for the step pulley section of the pull gear, and it will be machined into 3 stepped pulleys to take a Poly V belt. And this is the pattern for the cap section, which will take the 4 gears around that central pinion. It will also be locked in place when you want to engage the low speed for the pull gear. these are the castings, and although they're not the prettiest castings in the world, they will serve my purpose. So these are also surprisingly quite heavy, which might actually be a good thing. It's going to give it sort of a flywheel effect at low speed, especially when you're doing intermittent cuts like you might get with a fly cutter or a hole saw or something like that. So into the finished machined castings, we're going to fit 3 ball bearings. There are 2 that fit around the central spindle, which is going to be machined from this stock here, and the smaller ball bearing is going to fit inside the cap. I also have 4 sintered bronze bushes, which are going to be fitted inside each of these 4 gears that mesh around the outside of the pinion and the ring gear. So these gears are going to have to be bored out, and then the sintered bronze bush pushed in, pressed in, and I can impregnate those bushes with lubricant so that it should run pretty much maintenance free. I don't intend to show all of the machining process for this project. It's just there's too much of it. It's more about whether the mechanism works and how effective it's going to be when we're done. And it's going to be fun. We're cutting metal, we're making chips. What else could you want? Well, the first thing that I actually started to do with this ball gear was to fit the bronze bushes into these idler gears. These are 28 tooth module 1, that's metric, and these gears are unhardened. So when I bought them, they had a 8mm hole in the center. I think that's 8. Yep, 8mm hole in the center, and I wanted to run these on a 10mm stud, and I didn't like the idea of just running these directly onto the steel stud. So what I've done is I bought 4 sintered bronze bushes. These are 16mm OD, 10 ID, and they're 10mm thick, which is exactly the same as the gear. So the only issue is actually holding this gear and having it run true while you bore out the center of the gear. So what I've done is I've made a pretty rough and ready sort of chuck, which was machined in place, and the gear is a sort of a fairly good fit inside that aluminium collar. And the notion is you just press that in, and there are 3 grub screws around the outside, which I just lightly tighten down onto the gear. Now I've already done 3 of these and I haven't had a problem with anything slipping or moving. So what I'm going to do now is to drill out the center of the gear so I can get a boring bar in there. I'll bore close to sides, finish with a 16mm reamer, and then press these bronze bushes in. These are actually just over a thou bigger than the bore. So the finished size of this bush is about 16.04mm, which is just over a thou. So when I ream these to size, the bronze bush is still an interference fit. So let's go ahead, get this one ready, and I'm not going to show you all of it, but it's pretty straightforward. So you don't want to over tighten these little grub screws, so I don't know where they're actually bearing on the gear. If you're wondering what that big hole is there, that was just in the stock when I started. Okay, let's get drilling. Okay, so I've got a 16mm hand reamer in the tailstock, and I'm just going to feed this in at fairly low speed. And I want to go through nearly all the way, so the taper is still slightly engaged at the back of the gear, so that as I press that bush home it'll get really tight. You can sort of hear when the reamer starts to cut, it quietens down a bit. And that bush is just starting to engage at the front there, so that's how I'll leave that. So I'll just break that edge and then we'll press that baby home. Okay, so I'll get that bush in there and those 4 are done. Okay, so that's the last of the bronze bushes in the idler gears. Okay, what I've got here is the central spur gear. It's going to be mounted onto this shaft at a later stage, and I just roughly turned this. It's sort of about 0.2 millimeters oversized. This end's completely unfinished, and I need to be able to lock that spur gear to this shaft. So I'm going to cut a keyway in both parts, and I'll put a key in later on. So this fixture that I made up is made of some high-grade steel, and I've turned the bore to be a sort of a fairly tightish fit on the gear, and I've got a single grub screw holding that in place. There's a shoulder behind that gear because when I finish machining this bore, which is going to be finished 16 millimeters, I need to be able to cut the keyway, and I'm going to use a slotting attachment that I built for this lathe. So in order to withstand the cutting forces of the keyway cutter, it's got to have a fairly substantial shoulder behind it. So I'm going to go ahead now and finish boring this, and then I'll bring it to size with a reamer, and then later on I'll machine this shaft to be a tight fit. Alright, so that's bored to size. I'm going to leave that in there now because I need to be able to cut the keyway, so I don't want to disturb it. So let's get that underway. All set up for cutting the keyway on the inside of this pinion now. This is just a homemade slotting attachment I made for the lathe, and I've got this 4mm key steel which is going to be used to lock the pinion onto the shaft later. So I've got to cut my keyway, well, if it was half thickness it would be 2mm, but I don't have a lot of metal left in this spur gear here, so I think I'm going to probably only cut about 1.5 mm deep, and I've got my cross slide set, so as I'm cutting this I can monitor how deep that is. So this is a fairly tedious, slow sort of operation, so I'm not going to show you all of it. So let's see how we go. Alright, I think I'm going to stop there. It's certainly not 2mm deep, but I'm worried that I'm going to weaken the metal in this gear. Not that it's under a lot of load, but all it's going to do is resist the tendency for this gear to torque or spin on the shaft, and I think with the depth of keyway that I've got there, I'll do that. So let's stop there and get this out, and I'll just do a bit of tidying up. Okay, well there's the keyway. I think I'm going to have to sort of do a little bit of cleaning up to get the key to fit. It's not quite going in there, which is probably a good thing. Okay, I just gave that a bit of a clean up with a needle file, and the key is now fitting in there quite nicely. So it's sort of a firmish fit, which is what I want, and it's engaging in there deeply enough to stop that from spinning on the shaft. So I'll put this aside now. I'm going to turn the shaft to match that 16mm bore, and I'll just have to cut the keyway slot in the shaft with a 4mm end mill. Just finishing off the journals for the two bearings in the lower half of the pulley. So these are going to come in at 25.02 or 01. So I've got a press fit for the bearings. So there'll be one bearing here, one here, and I've already finished this size, which is just a boss to take a locking screw. So this can be fixed to the motor shaft. So that size not critical. These two have to be right, and there'll be another bearing journal up here. So I'm doing this all between centers, and I'm using high-speed steel tooling. This is a tangential tool holder, which is a bit problematic. It gets in the way up this end here, but I tried using insert tooling, and I just can't get the speed high enough to form decent chips, and the finish was pretty awful. So I'll stick with the high-speed steel, and I've got a lathe file here, and I'm just using this to dress these surfaces when I'm done, because the finish on this isn't brilliant. And I just need to finish off this shoulder here, so I'll zero my tool against this shoulder, which I know is correct, and I'll offset with this one and clean that up. And there's a few more diameters up this end to be done. But this particular part is pretty important. It's got to take all of the bearings, it's got to take the pinion, which drives the rest of the gear train, and the tolerances on this are fairly tight. I've got to bore this out at this end for the motor shaft, and there's not a lot of metal left by the time I do that, so I've just got to be a little bit on top of the dimensions here. Remember, all of this is just eyeballed from a set of drawings which had no dimensions, and it took me a long time to get all of these parts to sort of fit and to get their relationships right within the bounds of the constraints that I have on the drill press. So I'm expecting there'll be issues, but that's the fun of engineering. Well, there it is, nearly finished, at least on the outside anyway. I've got that pinion pressed on there. It's sort of just a nice snug fit, which is what I wanted. Top ball bearing is sort of getting tighter as I push it down. I wanted this to be a little bit undersized at the top here. There'll be a bearing either side of this boss here in the center here. And the next step is to start boring this out. It needs to be bored out, I think, 3 different diameters. The first one being for the motor shaft, and then there'll be a through hole right to the top where a spring will be fitted, and the latch that actually actuates the pull gear has to fit into a slot in the top here as well. So it's still a bit of work to be done, but I'm happy with what I've got so far. Okay, status report. I did a lot of machining today, about 5 or 6 hours on all of these parts, and some bits were really successful, some were a complete dismal failure. So let's start with the good ones. This top cap is now almost finished except for a single slot across the top here. That's where the latch will either drive this cap, or if you lift the latch up and rotate it, it will allow the cap to just freewheel, which is how you get the reduction gear. So this turned out quite well. I've got the single bearing just almost pressing home there now, and I'm not going to do anything with that until I finish all the machining. Oh, and by the way, there needs to be a drilled hole in the side or the circumference of this part, and it's going to be there so that a rod can be inserted into that and attached rigidly to the drill press. And what they will do is actually lock that cap in position while the rest of the assembly spins. So that's also got to be done. So that bit, thumbs up, all going well. I've also finished the central spindle pretty much, except once again for a slot across the top here, which is where the latch will allow you to lock or unlock this part. Spur gear sliding on, the bearings are going on there. There's a single 6mm hole, threaded hole for a grub screw which will lock this to the motor shaft, and there's an 8mm threaded hole which is going to give me a chance of putting a key in this part. Now I did think about using that slotting attachment to put a groove on the inside of that bore, but this is quite hard steel and I didn't like the chance of getting that, and I also didn't want to weaken the inside of this bore at all. So later on you'll see that I'm going to insert a grub screw with a square head on it, and that will engage in the groove of the motor shaft. So that bit, all looking good, happy with that. Right, I also did a lot of machining on this bottom assembly, and you can see the ring gears sort of ready to go on there. That'll be held on with 6 M4 screws, countersunk screws. The idler gears are all done and they're ready to go in place. They'll actually be fitted onto the top cap with studs, but for now you can just see how that assembly is going to work. I got to the point where I needed to machine the pulley grooves, or at least the V grooves for the Poly V drive, and I had a 40-degree included angle form tool which was just plunge cut straight into the stock, and I was doing the first groove, which was in the middle here, right at the very center, and almost finished, and there was a horrible crunching, tearing sound, and I realized that the tool had dug in. Now I sort of cleaned it up to the finished dimensions and kept going, and I stupidly cut all 9 of those plunge cut grooves, and then I got the air gun, cleaned it all out, and realized that there were pieces completely shattered, smashed and torn out. So that was a little bit of a blow, and I said a lot of bad words. I walked around the workshop for a while, kicked a few things, calmed down and realized that this is a total loss. I went ahead anyway and finished it. I finished the bores inside here, and I got all the bearings fitted and so on. I'm going to use this as a sort of I don't know, like a prototype, I guess. And what I'm doing now is I'm chasing down a piece of 6061 T6 alloy, 140 diameter, 60 long, and I'll carve out a new one from a better quality alloy. I don't know why this failed. I was using WD-40 as a coolant and a lubricant. I was taking it very, very slowly, but for some reason it just built up on the edge and just tore the guts out of it. So, yep, that's a total fail. No, not a fail, it's a setback, but I'll keep it, and you know, it would work. If I put the belt in there, it would drive and it would work. It just looks awful. I'm going to wind this video up here. It's going to be way too long, and in the next episode we're going to hopefully get all the parts made and do a trial assembly and just see whether it works. I'm keen to see how much reduction I can get with this. So my calculation is that it should be almost 5 to 1. This ring gear has 100 teeth. This little driver in the center has 24 teeth. My understanding is that these idler gears don't affect the ratio of the finished drive at all. They just simply transmit the central spur gear's torque through to the ring gear on the outside. So in a way it wouldn't matter how many teeth these idler gears had, it wouldn't affect the finish ratio. So my calculation is I'm going to get about 4.8 to 1 reduction. In the video I watched with Mr. Pete, he said that the one he had was going to give him a ratio of about 7 to 1, which I don't understand. I can't, with the physical dimensions of the one that he has and the number of teeth that you can effectively get into that assembly, I don't know how you do it, unless there's a sort of a double reduction, and in his assembly he wasn't able to get it apart. I haven't seen inside the one that he's got, so I don't know how that works. But nearly 5 to 1 is going to be okay for me. So I'll wind the video up here now. I'm going to ask you to like the video and share it. I don't normally beg people to do that, and I put up lots of videos on my channel, and average I get a couple hundred views. So I really would like to grow that and get more people to have a look at what I'm doing. I'm an amateur, but sometimes you see something and you think, oh, that's cool, I could do that, or that's a total waste of time, I'd do it differently. So yeah, look, like it, share it, do all that sort of stuff, and maybe I can put up better content. So I'm going to wind it up here now. Thanks for watching. See you on the next one.